And welcome everyone to the World Institute of Diginomics. My name is Travis, and in this course, we're going to be looking at how to embed data into the Bitcoin blockchain. The way that we're going to do this is using operational codes that are native to the Bitcoin protocol, and we're going to set up a full node in order to communicate with the network. In this way, we can timestamp data into the Bitcoin blockchain so that it is available anywhere and at any time. As long as we have access to a node, we can access the information that our node has embedded into the network. This is unique because unlike the World Wide Web of today, this method of storing data does not rely on a centralized component. We use Bitcoin's decentralized architecture to store information in a way that's censorship resistant and robust against tampering. When we use Bitcoin's decentralized architecture, we are not dependent on a physical machine. The information is stored in the cloud, so to speak, the cyber network of the Bitcoin economy. This is useful for individuals looking to gain sovereignty in geopolitical regimes that suppress freedom of expression and encroach upon civil liberties. Using Bitcoin's technology, we can harness a decentralized network and communicate with that network so that our information cannot be physically destroyed. Anyone who values freedom can understand how this technique that Bitcoin allows can be useful. And in this course, we're going to be communicating with the network through a Bitcoin node in order to write data to the network in order to use it as a sort of read-only memory. When we do this, we can have local machines interpret the data that's stored on the Bitcoin network in order to make use of it in local applications. This is interesting when we explore the potential of ISO images and downloading images from the network. You may have seen before how certain computer systems use a network install. We can connect directly to the network using our node in order to install ISO images that replicate a computer program on our local device. In this way, even if we lose the physical device, the data is not lost. Even if we have the physical device seized or confiscated, the data is stored in a decentralized blockchain architecture. In this course, we're going to show you how to do this, how to use the OP return function to embed files in the Bitcoin network and use your public-private key pair to sign off on data, authenticating it and timestamping it to the network where it has been cryptographically recorded by every node on that network. As you may well know, Bitcoin is an economy of networked machines. And when we store data on the network, each and every one of those nodes is a copy of this. Therefore, if we desire to have privacy, yet utilize the decentralized architecture of Bitcoin's blockchain, we must encrypt the data. We can retain the key necessary to decrypt the data locally, but what is published on the Bitcoin network itself must be encrypted. Let's take a quick look here at the full node we are in the process of setting up. The full node that we're setting up here is called Memtosis. This is the name of the machine node that we're establishing. And I'm going to go ahead and take a look at our Bitcoin repository, where we have a number of different programs. We have the Bitcoin Qt client, which is the graphical interface. We also have the Bitcoin daemon itself, which needs to be run in order to synchronize with the network. And I will remind the student here that the Bitcoin network, in order to run a full node, a full copy of this network must be synchronized locally to your machine. If you do not have the storage capacity for a full copy of the network, you'll not be able to run a full node. The Bitcoin blockchain is currently at just under 1 terabyte, meaning that you need to have a significant amount of storage space on your local device in order to run a full node. You may need specialized hardware. You may need to upgrade your GPU in order to process a full node on the Bitcoin network. The hardware requirements are progressively more demanding as the size of the network continues to increase over time. It is expected that at some point in the near future, the total blockchain size, the total size of the Bitcoin network will be at just over 1 terabyte. So you can see that if you want to run a full node, it's quite likely you'll have to purchase specialized hardware, such as an aftermarket hard drive. So as I was saying, in order to run a full node, we have to synchronize the entire Bitcoin network. So let's go ahead here and let's run the Bitcoin daemon. So what this is doing is synchronizing our local node with the network. And this will take a considerable amount of time. It'll take several hours at least. And you can see that each block that is being downloaded has a date attached to it. As we've just begun, the date is way back in 2010, 10th month of 2010. So if you're running a full node, it will take some time to establish this. And we suggest just being patient. But if you're interested in learning how to use the Bitcoin command line, then we suggest that you register for this course at $1 a piece. You'll have lifetime access, and we're going to look at how to write data to the Bitcoin network from the command line. So this program here, Bitcoin-CLI, is what we're going to be looking at primarily. And we're going to be using operational codes from the command line so that we can write data to the network. If we have Bitcoin in our wallet, we have write permissions in order to simply read the data on the network. We need to have a full node. In this course, we're going to have both read access and write access because we're going to actually have Bitcoin currency in our wallet. As I've said before, currency units are necessary to write to the network. And the way that we do this using the OP return function is by sending a raw transaction to the network with no outputs. It's meant simply as a communication between the node and the network without having a recipient. The data that's contained in the transaction is recorded by the network and it is hashed into a specific block on that network where it can be retrieved at a later date by some other node on the network. This allows us to use Bitcoin's decentralized architecture as a read-only memory, but that in itself has profound implications for the way information is stored and distributed. If you're interested in learning more, I suggest you register for this course. The tuition is $1. Go ahead, get registered. You'll have lifetime access. If you have questions or comments or suggestions for improving the course, you can send that to myself, the course instructor. But I am eager to get started on this so that we can learn more about Bitcoin and how to use it to our advantage. Anybody who enrolls in this course is free to share the content. However, what is prohibited is editing the video content associated with this course. It is copyrighted by Diginomics Corporation and the Institute itself. So although once you've paid the registration fee, you can download and you can share the course content, we simply ask you not to edit it in any manner. Thank you for watching this brief introduction to writing data to the Bitcoin network. We're excited to get started, and so we'll see you inside the course.